Welcome back, everyone, for lesson 9-7. This is going to be short and easy. All we learned to do on this day was how to graph all of the points that satisfied an equation like this, right down here at the bottom of the page. I made you work a lot harder for this lesson than in hindsight. We don't need to spend nearly as much time reviewing this. An equation like this has absolute value bars around it, and it has the subtraction sign. Okay, so that makes it different from an equation whose graph results in an ellipse. If it was PF1 plus PF2 is equal to something like, let's say 14, when there's a plus in between, then the set of points you get turns out to be an ellipse, right? And just as an aside, this number, when it's an ellipse, has to be longer than the distance from F1 to F2. Okay? If we want to graph a hyperbola, that number has to be shorter than the distance between F1 and F2. You put a subtraction in between these two values, and you throw absolute value bars around the subtraction so that you get both branches of the hyperbola. If we didn't have these absolute value bars, we would only get one branch or the other. If it's PF1 minus PF2 and we didn't have the absolute value bars, we would get the branch that's closer to PF2 and farther away from PF1. We'd get this branch over here only. But when we put the absolute value bars, we get them both. So to do this, right, you come up with some numbers that will subtract to get 8 instead of a couple numbers that will add to get 14. Sometimes, when you're first learning how to do this, sometimes students will have a little harder time coming up with numbers that fit this equation than this one. In this one, most of us have gotten into the habit of just, dividing that number in half, 7, and finding where circle 7 plus circle 7 intersect. But here, you can't divide that number in half and go, well, let's see, circle 4 and circle 4. They won't intersect at all. You need to start with some number that's larger than 8, because then you've got to subtract another value, right? So the smallest numbers you could start out with would be 9 and 1. 10 and 2 might also work, and 11 and 3, and so on. We could try 9 and 1. Let's see if that works. From F1, 1, 2, 3, 4, 5, 6, 7, 8, ninth circle, and the first circle from F2. So yeah, they do intersect each other. Sometimes when you start out with your smallest possible numbers, they won't even meet each other. Like for instance, if I had made this just a 6 instead of an 8, and then we said, well, let's see, 7 minus 1 is equal to 6. Then we would have gone to circle 1, 2, 3, 4, 5, 6, 7. There's circle 7. And circle 1 from the other focus is over here. They don't intersect at all. So 7 minus 1 wouldn't even work. We'd have to step up to 8 minus 2 before we found the first point in that graph. Anyway, 9 minus 1 does give us that point there. And then just like an ellipse, the collection of points, or the pattern of points, goes, I like to describe it as diagonally through the open space of this four-sided figure. Right? Now, these aren't really segments. This isn't really a polygon, but it's kind of like a diamond. Right? That space right there is kind of like a diamond. And so we're going from one corner of the diamond diagonally across the diamond to the next corner to find the next point, and then through that diamond space, and then through that diamond space. And the diamond spaces, of course, started out being very sort of long and skinny, and they get shorter and wider as we go, but they're still kind of diamond-like spaces. And you just plot as many points as you can till you get to the end of the graph. And don't forget to put arrows on. Right? The collection of points does not stop just because the number of circles that I've plotted for you stops. It'll go on forever. So put arrows at the end. And then make sure you've got a branch over here for the hyperbola that is a perfect mirror image of this one. Right? So this point here being exactly 1 unit to the left of F2, I know I can start this branch over here by finding a point which is 1 unit to the right of F1. And recall, the branches of a hyperbola always come in between the foci, right? An ellipse goes around the foci. The branches of a hyperbola always come in between the foci. Right? That's a key feature of hyperbolas that we relied upon in a lesson, 1 or 2 lessons from now, where when we're trying to come up with an equation for a hyperbola, or we're trying to locate certain points in a hyperbola, we got to keep in mind that the branches of the hyperbola come in between the foci, right? This might be considered right here the center of that hyperbola. You've got to remember that a focus in a hyperbola is farther away from the center than a vertex is. And these points right here, which are closest to the center of the hyperbola, which are closest to each other from one branch to the other, those are the vertices. Okay, in a hyperbola, vertices are closest to the center, and in an ellipse, the vertices are the points which are the farthest away from the center. Okay, that's really all there is to this lesson. On the back of this page, we just did one more example that in class I think I said, now try to do this on your own now that we've kind of figured out on the front what this thing is going to look like. So if here's the equation, and here's exactly what I was talking about. We might try starting with 7 minus 1, but 7 minus 1 doesn't work because from F1, 1, 2, 3, 4, 5, 6, 7, this would be the 7th circle here. And then from F2, the first circle is here. Those circles don't intersect anywhere. 7 minus 1 doesn't work. Right? How about 8 minus 2? Does 8 minus 2 work from this focus? 1, 2, 3, 4, 5, 6, 7, 8. There's circle 8. And then 1, 2. Yeah, those don't intersect either. I'll tell you what, it looks like I have the complete wrong result on these notes. Circle 8 and circle 2 do not intersect each other. That doesn't work either. Circles 9 and 3 should. From F1, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's circle 9. And from F2, 1, 2, 3. Those circles touch each other right there. That's a good point on the hyperbola. This one's not, and none of the rest of these are. Wow, that is a horrible mistake. I'm glad I found that. From here, then, we go diagonally through this point, through this space, to the next point, diagonally through to the next, 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 and to the next. Oh, be careful here. Put arrows on the ends. There's one branch. Now again, I can find the other branch by making sure that it's a mirror image of this one. This point right here is 1, 2, 3 units inside of F2. So the other branch has got to start 1, 2, 3 units inside of F1. And from there, it should go to here, to here, to here, to here, to here, to here, to here. And then from here down to there, to there, to there, to there, to there. Okay? So these branches, if we compare them to the branches on the front side, they kind of look taller and straighter, I would say, than these. These seem to be curved a little bit more sharply, right? So I'm still kind of blown away by what a bad mistake I made doing this the first time around. I've got another copy of these notes, I think. I wonder if I made that same mistake on both copies. I'm just curious now. Do I have another copy of these notes? 9-7. There's a clean copy of the notes. Yeah, I've got another copy right here. Right. There's the front side. There's the back side. Ah, no, on this one, I did it correctly. Okay, well, just wasting your time here. Let's take a quick look at the homework, very, very quick, and that's the end of the video for today. So I'm asking you to create graphs. Please pay attention to the changes in these equations. Here's one that should produce a hyperbola because it's minus with the absolute value bars. This is a plus, so it should produce an ellipse. Okay, here, hyperbola, here, ellipse. All right. And then on the second page of the homework is just more practice with completing the square for ellipse equations, turning equations from this form into what we call standard form for an ellipse. And quite honestly, I think you can decide whether or not you should practice that some more after the last assignment. Maybe you feel like you don't need to practice these again. You know perfectly well how to do these. You're always careful with your arithmetic. You don't make any mistakes. Fine. You decide. All right. But I think it'd be worth doing these 4 problems at least. They should go fairly quickly. Not going to take a big chunk out of your day. I thought I had one other little comment that I wanted to say before I said goodbye on this video. Let's see. Oh yeah, I just was going to point out that, again, going from a plus to a minus changes the graph here from the graph of an ellipse to a hyperbola. Also, in a very near future, in a near future lesson, we're going to see that if we have equations where the x squared and the y squared terms are being added together, then when we change this equation into standard form, we're going to have a plus there also, and it's going to be an ellipse. But if there is a minus in between these two terms, the x squared and the y squared, or maybe the y squared is positive and the x squared is negative, if one of them is positive and one of them is negative, then there's going to be a minus in between these fractions, and it's going to be the equation of a hyperbola. But that's to come in a future lesson, right? This is all you've got to do for today, and that's the last one for this week. Good luck.